Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 12, questions 35 to 36. And you probably would have noticed by now that this unit is discussing the citric acid cycle, or the tricarboxylic acid cycle, or the Krebs cycle, or however you want to call it, glycolysis of glucose, or the oxidation of ethanol. So there's a lot of ways to call this, but what's happening is we're just trying to produce ATP for energy in our body for the cells. Now, ACER is being a bit sneaky here. There's a couple of things they haven't told you. So if they told you what the structure of ATP was, you could have actually blitzed through these questions and answered 35 with ease, but they don't tell you what the chemical structure of ATP is, which makes it a bit more difficult. And if you did know this chemical structure of ATP, you know that to convert ADP, so adenosine diphosphate, to adenosine triphosphate, as we can see here, you have to add an inorganic phosphate. Inorganic means it doesn't contain carbon. Now, they're being a bit sneaky here, ACER, because in the diagram, they don't put, usually you see the little I under the P to show that it's inorganic phosphate. But they don't show that with the diagram, they just have it as P for phosphate. Don't get tricked here. The inorganic phosphate does not contain a carbon. It's going to help when we look at question 35. But let's just consider the fact that when we add an inorganic phosphate, ATP is just going to be, there's not going to be any change in carbon number. We're adding a phosphate group. So that's what we're doing here. So just note as well, we see in the key for the diagram that one NADH molecule is converted to 3 ATP molecules. And finally, for question 36, both ethanol and glucose, they share a common pathway after acetate. So obviously, we don't need to work out the ATP or NADH number after that point. We just have to work it out before that point to answer 36. But I mean, we'll go through it together anyway, just so we can all be on the same page. So question 35. Question 35, so mind you as well, for these sorts of questions in the GAMSAT, instead of just looking at the whole diagram and trying to confuse yourself, take a quick look at the question and orientate yourself with what you have to look at in the figure. So it says, which of glucose, oxalase acetate, and NADH, if labeled with the radioactive carbon, would result in the production of the 13C labeled ATP. Now remember what we said from the get-go. If you take a look at the diagram that ACER has provided, so we are getting ATP getting converted from ADP by addition of the phospho groups, so the inorganic phosphate groups. But you can notice that there is no transfer of carbon, because if you're adding an inorganic phosphate group, you're not adding carbon. So that means if we look through, say, for example, in glucose, so the half glucose to pyruvate, we're going to convert ADP to ATP, so we're going to get 2 ATPs. We're not adding a carbon there. If we go from pyruvate to acetate, we're not adding a carbon to the ATP. So the next time you're going to see ATP conversion is going to be from the citrate to oxaloacetate. And we're just converting ADP to ATP, but it's releasing carbon dioxide. So you can see the carbon dioxide isn't getting picked up anywhere in the ATP. So for question 35, therefore the answer has to be D, none of the above, because none of them are picking up that. So the ATP isn't picking up a carbon. And look, if ACER gave you at the beginning the structure of ADP and ATP, you would have known straight away that there is no carbon being transferred. So that's kind of the trick here. They did that on purpose because they wanted to see if you actually, and that's probably why they didn't include the little I next to the P, because if they did, you'd know it's inorganic phosphate. Inorganic means no carbon. So again, use some deductive reasoning to answer these sorts of questions. It would have helped if you had prior knowledge. You would have been blitzing these questions like that. But again, if you didn't have the prior knowledge, you could just think about logically, well, ATP is not picking up any carbons. So that's the key. So the answer for 35 is D. Now, if we move on to question 36, this one does require you to do some counting. It says, how many moles of ethanol are needed to produce as much ATP as would be produced by 1 mole of glucose? So let's just figure out how much ATP is being produced. Now remember, we're told in the answer key that one NADH molecule can be converted into 3 ATP molecules. So keep that in mind. So let's start with ethanol. So just for now, let's forget about after acetate, because after acetate, both glucose and ethanol go through the same pathway. So don't worry about after acetate. Let's just go towards acetate. So ethanol to ethanol is going to produce one NADH. So we're going to have, NADH, we're going to have, one, and then from ethanol to acetate, we're going to produce another NADH. So we're going to have two. So we have two NADHs. So equals 2. And remember what we said, one NADH molecule is converted to 3 ATP molecules. So we're going to therefore have 6 ATP molecules. Now bear in mind, ethanol here is shown as 1 mole. Glucose, on the other hand, is half a mole. So we've got half a mole of glucose. So keep that in mind. So what we're going to have is, we're going to have, NADH. So we're going to have an NADH, let's say ATP here. So we've got from glucose, so half glucose goes to pyruvate, which is going to give off NADH and 2 ATPs. And we're going to go from pyruvate to acetate, which is going to give us an NADH. So that means we have, remember, 3 ATP molecules for 1 NADH. So we've got 3, 6, 7, 8. So 8 ATP molecules. But remember, it's only half a mole of glucose. So we've got to times this by 2 to get the 1 mole, because the question is asking produced by 1 mole of glucose. So we times this by 2. So the answer is 16 ATP. I mean, we can stop there, answer the question, and we can get the right answer. So the answer you could tell, therefore, is there's going to be, if you do 18 divided by 6 is 3. But 6 times 3 is going to be 18. So it's somewhere in between, obviously, 2 and 3. So it's going to be more than 2, but less than 3. But 16 divided by 6 is going to be about 2.6, 2.7. So your answer, therefore, is going to be, when it says how many moles of ethanol are needed to produce as much ATP as 1 mole of glucose, well, it has to be more than 2, but less than 3. But ACER has more than 2, less than 4. So it is C. But, we might as well finish it off. And you probably would have remembered how much ATP you generate from the Krebs cycle or the citric acid cycle or the tricarboxylic acid cycle. One thing I like to tell students is that TCA does not mean the citric acid cycle. TCA means tricarboxylic acid cycle. So that's a little thing I like to tell the students, because it is a mind-blowing moment for some students. So let's take a look at it from acetyl-CoA. So let's take a look at it from the ethanol point of view. So we already have our 6 ATP. Now let's add some more. So we're going to have from acetyl-CoA to citrate, then to oxaloacetate, we're going to have 1 ATP and 3 ADH. So we're going to have plus 1 ATP plus, 3 NADH means we're going to have, 3, 6, 9, so plus 9 ATP molecules. So out of this reaction with ethanol, so the oxidation of ethanol, we're going to produce 16 ATP molecules. Now let's look at glucose. Remember, keep in mind, glucose, we were given a half a mole here. So at glucose, we're going to still have at the beginning, so let's just keep it at half a mole. So we had 8 ATP at half, so half glucose equals 8 ATP, write that again, 8 ATP plus, so we're going to go again, 1 ATP, 9 ATP, because it's the same process, so it's going to be plus 10 equals 18 ATP. But remember, we started off with half a mole glucose, so if we times that by 2, times that by 2, and you're probably told citric acid cycle produces 36 ATP, and voila. So that's how we convert it. You probably would have memorized how much ATP is produced from the citric acid cycle, but that wouldn't have helped you here. So this is why ACER asked this question in this way, because they know that people know, if you've read back to front textbooks about citric acid cycle, how much ATP is produced, but what is the actual ratio produced compared to other oxidation of other compounds and molecules like ethanol. So if you're still having any difficulty, or if you have more queries about this unit, you can pop your comments in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.